And welcome along to the latest Smart Cities World webinar. Today brought to you in association with Hexagon. My name is Luke Antonio, Senior Editor for Smart Cities World, and for the next hour or so, I'll be your host for this webinar. We have a really great session lined up for you today on a topic that has been, I'd say, extremely popular with our members in the last year or so, urban digital twins. And we're going to be hearing from Rotterdam together with IMAGEM and Hexagon about their establishment of a digital twin ecosystem and how that is supporting their priorities and objectives to become more resilient. So without any further ado, let's meet our speakers for this session. Please come along, join me on screen. Let's see you all. So Corne, Uwe, Niels, welcome along. Great to have you with us. Before we kick things off in true fashion, let's get a quick introduction from each of you. Find out a little bit about who you are, kind of the angle that you're approaching this conversation from today. I'll come to you in the order that you appear on my screen. So Corne, that puts you first. Welcome along.
Yes, good afternoon. My name is Corne Helmels. I work for the Municipality of Rotterdam. As a tech lead for the development and the maintenance of the 3D city model that we have within Rotterdam. And I want to take you along with us in the journey that we have made the past couple of years towards an ecosystem of applications, of digital twin applications, I must say, that helps us making data-driven decisions and work more efficiently within the municipality.
Brilliant. That is the name of the game. Looking forward to hearing more. Niels, let's come to you.
Yes, hi, I'm Niels van der Graaf, and I work at IMAGEM, and IMAGEM is a Dutch company and Hexagon partner in, let's call it vision computing, and by that we create digital twins, interactive and dynamics, for model predictions, and we help mainly our governments for urban planning situations.
Wonderful. Last but certainly not least, Uwe, let's hand to you.
Thanks a lot. Good day, good morning, good afternoon, wherever you are. So I'm Uwe. I have the pleasure of working for Hexagon and orchestrate the business of government, transportation and defense in Europe, Middle East and Africa. And everything around digital twins is a hot topic for us. We apply them on all different elements, also within the notion of cities and regions and nations. And today I'm bringing some ideas about how to enrich and go a little bit beyond what Rotterdam is currently doing together with our great partner IMAGEM, and talk a little bit about climate simulations and what you can do and what you can reach with climate simulations. Some goes, no goes, and some hopefully cool insights which attracts you to think more about climate simulations.
Excellent. Thank you very much. And again, looking forward to hearing more. Those do's and don'ts, always very valuable. So we'll get to that in a little while. So we have a few presentations coming up in this webinar today. The first person you'll hear from will be Corne in Rotterdam. But before we get to that, just a quick reminder to those of you who have joined us live. The Q&A is open throughout this session. So if there's something that you hear that you want to follow up with, please make the most of our speakers' time while we have them on the call. Submit your questions and we'll get through as many as we can once we're through the presentations. Similarly, the chat is open to everyone to use as well. So, you know, if you don't necessarily have a question, but you might just want to reflect on something you've heard, share an insight of your own, feel free to do so. It helps to, you know, open the conversation up and make this more of a dialogue. We want you to be engaged in the session and get from it what you can. So make sure, make sure you're using the tools at your disposal. Without any further ado though, Corne, let me hand to you and we'll kick things off. I'll just stay on while your slides come up just to confirm that we can see them.
Yes, thank you, Luke.
All right, so we can see you and we can see your slides, but not in presentation view. We just see the PowerPoint window at the moment. That's perfect.
Now it should pop up, yeah.
Wonderful.
Well, thanks a lot for hosting this this wonderful webinar. My name is Corné Helmons. I work for the Municipality of Rotterdam. I do this for the Department of City Management on behalf of the Department of Geoinformation. And as I've already told, we in Rotterdam, we are for quite a while, we've been working on a 3D city model. But it's not only about a 3D city model, but then you have a 3D copy of your city, but what to do with it. So what I want to take you on with is the journey that we've made based on an actual use case in the city of Rotterdam. And that is the Rotterdam Weatherwise program that we have. And I think everyone recognizes it that we must admit that the climate change is just a reality and we have to deal with it as municipalities. And in the situation of Rotterdam, we are quite vulnerable since we are situated in a river delta. And the most irritating thing is that we are below 85% of the area, we are below the sea level. So regarding the water management, you can imagine that we have some serious issues when the heavy rainfall will get more extreme, and at the same time the seawater level is rising. But we have other challenges ahead as well, since we are a quite densely built city that's hard paved and full of concrete buildings. We also see the risk of the accumulation of the heat. So the heat stress is an actual real topic for the municipality as well. And I believe that as Rotterdam, we must develop and design and manage the city to be climate proof. And we can't do this alone. So that's why we arranged this program Weatherwise, where we want to reach our goals for the period of now until 2030. And in order to do so, we're trying to make the most out of the available space that we have in the city. Since it's so densely built, we have to combine several functionalities all in one. These are some examples of a water storage facility. During the day when the sun is shining, it's a nice place for the students of the school to study and to play some sports and to relax a little bit. But when the rain starts falling down, it actually acts like a buffer where we can storage the first flooding to make sure that we can infiltrate it into the soil after the rain stops pouring down on us, and we can just let it flow away fluently to the sewage system. And on the right side, you will see a combination of a dike, primarily water feature for us, since we're situated alongst the Maas, the river the Maas, which is an open sea connection. So we are quite vulnerable to the sea level rising. So this is a primarily dike that's combined with some shops, some stores. And on top of it, you will see a green park on the roofs so that we can combine the functionality of water management with the public space as well, to make most of the available space that we have. And if you want to keep your city truly climate resilient, we face a couple of other challenges as well. I mean, the challenges that we face are multidisciplinary. Like the solution, we want to address our storage of fresh water services on top of the roofs, but you will also want to have some solar power on your roofs, or you want to add some greenery on the roofs, just to make the biodiversity and the whole ecological impact quite a lot better. And the same goes for the public space. I mean, you can address parks and trees or water bodies in it, but you can't do it all together, because you also need some space for parking and for the citizens to drive. So it is quite a complex system that's interconnected between each other. And in order to make the right choices, it's not only necessary that we understand the problems that we face, but also we need to address the public understanding of the challenges that we face. So we need to talk about this in a more comprehensive way, so that everyone can pitch in and give their feedback on the choices that we need to make. And by doing so, I believe that we can really start with civil participation and that we can collaborate with all the stakeholders of the city, because it's not only the municipality of Rotterdam that's in control of the city. The city is for the citizens first. So we need to be able to talk with them on the same level, on the same information, and we can't do that any longer with the normal way of dealing with these advice, thick advice reports with some technical drawings behind it. We really want to be able to visualize it in a way that everyone understands it, and that's where the digital twin comes into play. And as I've said, it's not only about the municipality. So I think we have quite a lot of data sources that we need in order to make this work. So we will have the data sources from Rotterdam, we will have them from the water company, we will have them from private companies as well, regarding water, regarding houses, regarding features in the public domain. And all these data sources need to be combined. And how do we do that? Well, in the city of Rotterdam, we have developed the Open platform and see it as a catalog on steroids. For us, it's the place where we can register all our data services, and not only from us, but also from the whole wide world. So that everyone can register their data and make it interoperable through open API, through OGC standards, so that the data sets can be addressed and can be used, so that in the end we get a cross-domain interconnected system. So it's not only for us, it's for the whole municipality. And it's not only about the data, it's also about the apps that rely on those data services as well. And I think I have a problem. I see a bus stopping with a package, but let's hope the dogs don't bark that hard. And we also need to connect the data service to the applications in order to make everything really truly interoperable, so that we can build on scalable solutions. But first, I want to take you with in Rotterdam 3D platform that we have. See, this is a web-based service where we keep our data sets maintained and published for a broader audience. So this is just available for everyone. It's scalable through for all devices, for like iPhones, iPads, or whatever. Well, in the end, it doesn't make a difference. And on top of this portal, we have the database that's actually being used to update all the services. And for the maintaining of these services, we use a couple of technologies that we have in place in the city. So we have the airborne LiDAR scan, we have the mobile LiDAR scans mounted on top of cars, so that we can do the surveying multiple times a year. And from the results that we get, we use point cloud classification and vectorization to derive the different products and the information that we need out of it. And then we can translate this into a digital twin data set, so that we are able to update our database and eventually our data services that we can use within a whole range of applications. Now, in this digital twin ecosystem that we are talking about, we are working closely together with the Dutch Normalization Institute, GeoNovum. That is running the NLDT ADEC program for us within the Netherlands, and that's a European-based bigger scale program, where we describe the overall architecture of building an ecosystem for digital twins. So what we are trying to do within Rotterdam is we want to keep the solutions really separated, so that they are scalable and connectable. So we have a data silo, we have analyst modules, we have visualization application, and we combine everything together through the fundament based on APIs and open standards. By doing it in this way, we make sure that we don't get a vendor lock-in, and we have everything interoperable and reusable. So this is just an example of the open platform that we have, the catalogs where we can register the data services and the applications, and one of the showcases of IMAGEM where they simulate the rainfall and the water levels within a digital twin application. And one of the nice things that we came across in this whole process is that a couple of years ago we run a big program in the Municipality of Rotterdam. It's called Totally 3D. It was a big collaboration between Rotterdam, The Hague, and Amsterdam, where we worked on the integration of the 3DI platform, the rainfall simulation tool from Nederlands Schuurmans. And we did that based on our web viewer for Rotterdam 3D. And that was just the first primarily tool that showed the results of a rainfall simulation and just as plain 2D GIS web services. But it was the first step. And after we successfully delivered that project, we kind of stopped the further development for, I think it was a year. But during that year, the best part was that IMAGEM was talking to another municipality, also with the same party, Nederlands Schuurmans, with the 3DI platform, and they were working on implementing the same analysis results, but then with an extra 3D tile service in it. So you could actually see the water levels rising within that service. And I think the best part was that after that project was delivered, I got a call from Nederlands Schuurmans, and they told me, oh, well, we've done something really cool together with IMAGEM. I want you to have a look and try to embed this within the Rotterdam ecosystem and see that we can develop this any further. And that's what we did. So based on the ecosystem the architecture that I was talking about of GeoNovum, last year we made a presentation, or actually a demonstration, I think it is, you should call it, about the integration of the whole ecosystem. So we have the data service of Rotterdam 3D. We have the open platform where you can register our data services. And when you combine everything together, it looks kind of like this. So this is the register of the open platform where all our data services are addressed. And from here, you can just run your visualization application. And for this example, it's Unreal, but this can also be IMAGEM or whatever sort of platform you are using currently. From this connection, you will get an answer of the server which services are already available and discoverable for you, so that you can just click and add those to your digital twin experience straight away. So based on your information needs, the user can just configure their own digital twin experience and visualize the data sets that we have. And these are actually the same data sets that we already had in the online platform. And this is an integration with the heat stress analysis. This is still a pre-calculated result, but the idea is that within the next couple of months we are going to work further on making a dynamic connection, so that we can not only show pre-calculated results, but also really start working with those tools through API calls, so that we can do it on the fly and manipulate the analysis parameters. And this is actually the result of the integration with the 3DI, with the rainfall simulation. So now you can see the water levels rising, and it starts raining within the engine, and you can see the effect of the water levels on the buildings that it has. And this was just a bonus from us from the project that IMAGEM did together with, I think it was the city of Almere. And we did the same with the dot mobility platform. This is a traffic simulation, traffic prediction system, so that you can see the real-time traffic information, but you can also see historical data sets and make predictions about future situations, so that you can really play around with the effects that it has on the city. And yeah, well, it is a digital twin ecosystem, and that means that it's getting quite big in the end. I mean, on the data service side, we have like 2D geographic streaming data. We also have BIM data. We have 3D tiles. We have sensor things APIs. We have BIM data like IFC that's also being converted to 3D tiles. And it's quite a lot of application that we have connected at this moment. And we have the same for the calculation models. So we have the analyst platforms like 3DI for the water management, Tiger on heat stress, dot mobility for the mobility issues, Synexis for traffic and pollution and noise calculations. And everything is streamed through OGC 3D tiles or WMS, WFS services. And on top of that, for the visualization part, we are not only looking into Unreal as a desktop application, but also on web-based applications like VCMap, PlanSpace from IMAGEM based on Lucia Hexagon technology. For AR, we are looking into MyVR at this moment together with IMAGEM. And we are also collaborating with a local company, the 360 Fabric, that's building an implementation based on Unity. And for VR, we are looking into desktop applications, but also on web-based and also right into the goggles. That's quite challenging since we're using streaming technology, but in the end, I think we will get it up and running. And the whole idea is that within the OpenUM platform, we can configure all our available data services, all our application, and we can combine those into a digital twin experience. And that configuration is streamed directly to the visualization application. So in a web-based environment, you can configure your whole digital twin experience once, and you can reuse it over and over again in the application to your liking. Well, and since this is quite a journey, we've already built some sort of a roadmap. It's not 100% rock solid, but at this moment, I think we have emerged from the state of a static digital twin where our data services are available, and we can start running projects in it, to some sort of a connected urban twin, where we can make sure that we use the architecture that's underneath the whole ecosystem thought. We are looking into data space solutions at this moment, and also with VR and AR visualization things. So that I think we have the fundament for next year to work on a more dynamic digital twin, where we can also support the design processes, and we have VR and AR interactions with users among each other. We want to incorporate sensor data so that we can visualize it also, and that brings the twin more to life as it is now. And we want to work on some AI integration, like chatbots, and translate it into queries, so that we have the fundament for, I think, on a larger view for 2028. We can really start supporting the participation process, so that we can have real interaction with all the citizens. And we want to have some AI real-time analysis, like a flood early warning system, so that we can actually make some signals based on weather forecast, and make sure that we have everyone informed about the risk that we are seeing. And in the end, we want to support our emergency rescue services with some simulation and coordination proof of concepts. I think we should address it. So, well, this is what we are working on in the city of Rotterdam. Thanks a lot for your time and having me here. And Niels, I think it's up to you now.
Thank you, Corné, and I will take it over. I will show you in about 8 to 9 minutes the examples of the solutions, the digital twin that we have created. And the interesting thing about it is that, as Corné explained with their OpenUM platform, we get all the data out of that so that we can create our solutions. So I will share my screen and I will show you a video, and this video will share the applications. As you can see here now, Corné was talking about the rainfall, which can flood areas, and here you can see the simulation or prediction, if you will, about what happens if a typical large rain shower will fall. within an hour. And you can see here on the facades how high the water will be. Then you can see here the 3D buildings and the planned buildings what Rotterdam is working on in the future. And all the reason is why to do it in this way is it gives much more context and it gives much more perspective. So everybody, even non-technical persons, will know what will happen. Here you can see a bridge also being into the digital twin from BIM models, IFC models, and we fly through it like a drone. It's a feature to fly throughout the city or area, what you want to, as a walkthrough, but then via a drone. We use the Luciad technology for this, so not a game engine, but a technology for geospatial data with 3D engines in there. And here you can see it, you can have unlimited point clouds together with other object kinds of methods for trees. Here you can see the point clouds of the Municipality of Rotterdam, actually. That's their office building, also a hotel and some other offices there. A ship is there as well, also being shown. But just to show you that you can use 3D objects as well as point clouds, here you can see the shadow analysis for a planned building, and you see immediately that which shadow it will cast over other buildings. This is also quite interesting. This is from a drone, so you can also fly with drones, use the drone software to create a 3D mesh, and you can instantly use it, show it into your digital twin. You can walk through it, you can do measurements, and all at the ease of a button. Then something we are also quite proud of, a collaboration with a Dutch company for presenting 3D high-quality meshes. So that will be shown here. It's from HXDR. And you can see here also the same part of Rotterdam, which I've just shown you, but in a different resolution. And now we will work with BIM models, the IFC model. And there are several ways to do it. I can just create a catalog by drop and dragging the object and placing it in an area just to create a situation. Let's also put there an office building. And again, this is for easily showing what could it be look like when you are really planning a situation like that. We also have an automatic conversion of IFC models to the digital twin to make it as easy as possible for the user. You just point out where you want the building to be, and it will place it exactly where you point. And this is quite difficult because most of the architects or project companies create IFC models, but not geographically. And we've created a way so that the user can easily change the position of the building. And then again, I can put it anywhere I would like. I can do my measurements, I can do my analysis, I can do anything with it, what I want. I can look through the tree information in there. I can look through all the details in there and use it for whatever process. Lastly, in this video, also some prediction on the deformation of the soil. So we point out here the area where we want to build. There's a calculation on there which is telling me which part of that area will have troubles with deformation and which area will not. So it will easily tell me where it is possible to build or not. Then I will switch. This one can go. Let me just switch it here to another screen, and then there's two small real-life examples, and then my part is done. And the reason I wanted to show you this as well is to show you that if you have 3D objects, you can start by building your digital twin. We can see here the housing, which Rotterdam has also in their open urban platform. We can use it I can use it for instance, looking where there are, for instance, sewages or cables underground. I can use it any data I would like to have, for instance, the trees. I can have several kinds of trees. The most popular, the lollipops, of course. I can use the trees with the textures, which is also in the same database in there. It's not. Here we go. There's it coming. It's loading the complete of the Rotterdam, and because I'm using Zoom, it takes quite a little, just a little bit more time. But I can also get the point cloud of the vegetation. So just wanted to show you here how easily you can use several kinds of data. It's all open standards, and I think that's the best way of sharing the information. And as you can see, it's a complete of Rotterdam, and the performance is actually quite good even when using the Zoom application. Also wanted to show you when you convert a IFC model, if it is a large model, a small model, or a point cloud, doesn't really matter to us. You can upload these data, and it will convert the IFC model to a 3D OGC 3D tile. And I can upload, there's an upload button here, to the Open Urban Platform of Rotterdam, so that anybody else also who has access to this Open Urban Platform can easily connect to that data. Last but not least, we also have a new digital twin for the Municipality of Rotterdam, for deciding which of the 250,000 houses can be taken off gas. Oh, hold on. Yeah, here we go. And my colleague Reinier will talk to you in 3 minutes' time what we are doing here.
3 minutes, not very short. Hello all, good afternoon, good morning, wherever you are. Yeah, this is currently a project we're doing together with Rotterdam. Rotterdam has a huge challenge of trying to get 265,000 houses off the gas and get a more sustainable alternative for it. Rotterdam has done all kinds of calculations to determine what would be the best alternative for each house. What you see here, it's sadly all in Dutch. But I'll try my best translations. A legend with the 4 alternatives. We have a heat system. We have individual and collective heat pumps, and we have a thermal energy storage system, basically. And all the calculations are being done, so we can see per neighborhood, per house, what the best alternative is, what the second best alternative is, and so on. There are multiple scenarios where we calculate based on temperature and isolation what the best alternative would be. So we're looking now at low temperature, but we also have medium and high, and you don't see much change in this neighborhood, but there are neighborhoods where you can see more change between the different temperatures. So we have the different neighborhoods. All neighborhoods of Rotterdam are in here. It's still work in progress. This one is not loading, sadly. It might have disconnected. I'll go back to the first example. Yes, so for every neighborhood, this has been calculated. On the left, we can see the average costs for each alternative. These costs include literally everything. It's costs of pipes, transport, heat costs, fixed cost, variable cost, anything. And what we also do is create graphs of this and group all these costs together in different categories. Yeah, that's it. We continue working on this. This is a very interesting project where we combine digital twin and dashboarding.
Yeah, in summary, it's a very interesting project because we use lots of BI data, combine it with 3D, and create a digital twin for the knowledge workers to make decisions on which housing is most effectively possible to take off gas. So that's it. The next speaker can take over the presentation.
Cool, I do my very best. And And here we go. Hope you see my screen.
Yep, all good.
Perfect. So thanks a lot, Corné. Thanks a lot, Niels, for setting the stage. And as Corné really nicely pointed out, when we speak about digital twins, urban digital twins, it's a kind of an ecosystem. So we have multiple elements within this ecosystem for visualization, for IoT stuff, for the models, for the semantics. And I'm going to show what we are going here to do here with the climate simulations, which we apply in different twins. When we talk about climate simulation, I think we first need to go a little bit about, okay, what do we need for that? And first of all, of course, we do need a 3D city model because that sets the scene, that sets the context, that sets the frame. So that's what's needed. And we have seen now so far a lot of beautiful visualizations of the Rotterdam model. So congratulations to that one, Connie. The next step is actually that we do need kind of semantic. And so semantic is needed because we need to understand when we start in the climate simulations, what is a building, what is a roof, what is a sealed area, what is an unsealed area, where are the trees, what is the height of the trees, what is the density of the trees. So we need a lot of semantics in order to set the scene for the simulation. And the simulation itself, it's indicated in that picture to the right. It's actually going to the third dimension. So semantics we do primarily in the second one in 2D, but with the simulation we are going to show up the third dimension. And the remarkable part of these kind of visualization as an element is basically what we are going to do is in the simulation arena, we're going to form voxels, which is a volumetric pixel at the end. And the majority of the voxels we do not show because these are the ones which are the open space, the open air. But we do need to keep the voxel even in the empty space, in the virtually empty space, because one of the key topics when we speak about simulation, when it comes to heat and these things is wind, because wind is one of the key features besides humidity, which gives us a notion about the intensity of heat, which is caused initially by solar radiation, but the wind can bring it out. And after we run the simulation, we need a tool like Niels was showing pretty nicely, and also Corné, on how to visualize the results. And then we start tweaking the scenario. Means we can go ahead and exchange open space with building or building with open space. We can change sealed areas to unsealed areas. And then we can run what if scenarios. And these could be pretty simple ones like converting a parking lot, which is gray space, to green space. Or we're going to plant trees because when you look around, one of the key activities and counter measurements you're going to do is planting trees. But the key here is really, if you really want to plant trees which has an impact, these trees are pretty expensive because you need a certain height. And you better make sure that the location you're going to select is really based on the effect this the trees are really creating, and then you visualize, and then you go through the scenarios. Now, I will start a little bit with the land classification, just to give you an idea how it looks like. So we have done ourselves a big favor and took the data from Germany, Austria, and Switzerland, and we were strictly forward going through the land classification. And as you can see in this non-cutted video, you're going to select any kind of location in these three countries, and you will get the semantics. What is green space? What is blue space? What is green space? Where are the building? Where are the trees? So this is setting the scene. And of course, this is working also outside of these three countries. But this is the basis, and on top of this basis, we start then the simulation. And as I said already, wind is one of the key elements. Even if we talk about the heat, the wind is a key driver. And you can, of course, also simulate only wind. And why is that important? If you go to cities which has an interesting topology, like for example, being in a valley, the notion of fine dust particles and bring them out of the city is primarily driven by wind axis you have. So you need to plan the city that you bring in fresh air, get out the dusty air. And in order to do so, you need to make a wind simulation. And also notable is that even if you're going to make a wind simulation or you're interested in something like a square kilometer within a town, in order to make it correct, you're going to take the square kilometer in the town, then you need to make a buffer outside, which is a little bit less detailed. And then you make the next buffer, which is even lesser detailed, in order to really have a correct streaming of the wind on the area of your interest, because obviously wind do not start out of the blue and ends up in the blue. So you need to really go ahead and have a fine model and enlarge this model in order to make this correct. And here is a simulation from Austria. They do have a building which is not longer in use. And so we have here an LOD2 model. And the question is, okay, what happens if you're going to remove the building? And how does it affect the wind stream in that quarter? And as you can see here, this is a situation when we do have the building active. And then you see here how the wind streams are and what is the speed of the wind. As you can see, you have here some blocking factors. If you're going to remove that one, we see that we get a pretty nice corridor with a good through-streamed wind channel, which is pretty nice. And of course, next step, but this is for political reasons not appropriate to show in a webinar. You can go there and go ahead with IFC models and then show how these IFC models will affect the area. But just by removing that building, you can also create a delta card which says, okay, what's the difference between with or without the building? So this is a pretty cool tool for the city planners, if they really want to think about, okay, if I do have a change in the existing scenario, how is this affecting the wind situation? Or as Cornet and also Niels showed, if I'm going to plan new buildings, new changes in quarter, how does it affect the wind situation in the quarter? Similar, we can go with the heat simulation. So basically, this is the inner part of the city of Klagenfurt, one of our reference customers here. And in order to do the simulation, you need to give the wind direction, the wind speed, obviously, then some surrounding area elements, but also the heat, the wind temperature, the water temperature, and also the humidity, because the humidity is very important when you start about how do you really, what is the reception of that heat? The higher the humidity, the worse the feeling. Now, when we run the simulation, we end up with something like that. That's the way it is. And so we see here, obviously, a little bit a not so hot area. This is when we go back. These are here these two bush areas. And also we see here the trees, and we see here in the middle of the structure that they have some hotter areas. So that's pretty cool. We had the luxury of having a customer of ours who was doing some thermal flights, and we gave ourselves a challenge, and we're starting and running a simulation against the real captured data. So we asked the weather forecast for giving us the date with the attributes with the temperature, relative humidity, and then we run the simulation. And lucky we had virtually no deviation. It was about a maximum 1 degree Celsius. Now, the next step is obviously, as I said, we are going to plant some trees, and we plant different trees, conifer trees, leaf trees, different heights, different diameters, and then just rerun the simulation and see what happens. And to no one's surprise, well, you see that where the shadow temperature decreases. That's obviously pretty cool, but also not rocket science because it's what you expect. But now it comes to the tricky part. I mean, we do have a temperature decreasing there on the ground, but unless you're coming from the Oktoberfest and pretty drunken, you do not breathe close to the ground. You breathe in 1.50 meters, 1.88 depending on your size. That means, and the heat is a beast in terms of that it changed temperature pretty much in distance. So what we are also doing in order to make it more concrete, we go to an ISO standard, which is the wet bulb globe temperature standard, and he defines in a certain height how you're going to measure and simulate the data and retrieve an index. And funny enough, a lot of sportsmen do know these index because, for example, in the last World Championship on soccer, the drinking pauses were defined by these index. And you can see here that depending on the index, you see the threat to the different age classes. So that's really an interesting one because it's not on the ground. It's in a certain height, and this is really the relevant part for that. And the cool thing on what we have done is that we have a complete round trip automated. Means we can generate automatically the semantics. We do have a user interface to interactively analyze the scenarios and set the parameters. We run the simulation, we display the result, and then we start looping it. And that's, from my perspective, what's exactly needed if we really want to change something on a very solid basis. And with that, thank you very much. And together with the colleagues, we are more than happy to answer the questions which are there.
Wonderful. Thank you all very much indeed. And we have got quite a few questions that are starting to pop in now. So I think we'll jump straight to them. So Corne, Niels, feel free to come back and join us. I know you guys have been answering a couple by typing your answers as well, which is great. So let's have a look at the first one that we've got in the list. So this came in, Uwe, while you were speaking. When you are talking about climate simulation, can you get that to show its harmful effects on various assets and infrastructure?
Sure, as long as you tell me what is the harmful effect for the infrastructure. So obviously we can simulate what is the heat penetration, what is the maybe the particle penetration, whatever it is. But the question of if this is harmful or not, this is an expert question, and we are not the experts for these answers. So that means we can give you the tools, or we give the experts the tools and bring everything together. But the assessment, we need to delegate to the ones who are really in this business. I mean, like, Cornes and his team, he will have these guys available on his fingertips, I hope, to answer these topics. I mean, not every simulation is as simple as like a flooding one where you see, so now 2 meters, it gets a little bit dense with breathing. These kind of simulations are a little bit more tricky for these things.
Yeah,
I think
sure.
the real answer lies in the definition of the KPIs that you want to address.
Yeah.
And as long as you have established those values, then you can use all sort of calculations and visualize the direct effects and the only KPIs this.
Absolutely correct.
Great. Niels, anything to add on that before we move to our next question?
Sorry, what was your question?
Anything to add on that before?
Oh, yeah. Like Cornel also stated, and Uwe, when we have these kinds of prediction models, these are very complex, and mostly these specific kind of specialists, they have all these calculations in their system. So we just, with an API, we address this calculation. We do the calculation is being done on their side with their knowledge, and we just visualize it.
Yeah.
So in regards to this question, if it is harmful, in the Netherlands, we have an organization that does these kinds of calculations. For instance, when there is too much heat, what will this do to trees, for instance? If the calculation is there, we just connect to it, get the result, and show the result.
Okay, great. So let's have a quick look. So one that's just come in, which I think is useful. So are you, in your project in Rotterdam, are you training this? Are you basing this on the simulation with, you know, real situations that are, you know, that you're anticipating or that you have experienced in the past? How are you really approaching, you know, what's there and lining up the work you're doing with the digital twin with city strategy, I suppose?
To whom are you
Okay.
asking the question?
Connie. I
Yeah, it's
think it's for
Corne.
Connie.
Yeah.
Yeah, I'm thinking about it, and I think that the thing is, as I've stated in my roadmap, we are now focusing on using the calculation models. And one of the next step is that we also want to incorporate the Sensor Things API, so that we really can start the measurements and start interacting and start reviewing the predictive models against the measured values. And we have some sort of we have all sort of networks available in the city of Rotterdam. So we have sensors within the sewage system for the water flows. We have sensors that are registering the culverts. We also have sensors in the light posts for temperature measurements and all those sort of things. But that's really the next step, that we can calculate it and that we can validate it, but also validate our and review the performance of our assets based on the calculation. So if you, for example, for the sewer system, if you know that you should expect a flow of well, just a flow based on the actual rainfall, and you're registering quite a lower flow within the sewage system in your sensors, then you know that there is something happening within the system of your sewer system. Then there is some sort of an obstruction somewhere in the system, and you need to do something about it. So you will always have design calculations that are based on design values, and you will have measurements that are based on the actual situation outside. So it's in the end, it's not matching up, it's not aligning, but it tells you something about the performance of your assets in the real world.
Yeah, for sure.
I'd like to add to that, because in the water flood situation we have shown today, this company is specialized in these hydrologic models. They do actual real life testing if these models are accurate. So every time when there is a heavy rainfall, could be anywhere in the world, they will go out and do the measurement and test if these predictions are still okay.
And my small comment to that one, we are currently really probing the added value of using environmental sensors in the climate simulation. Means instead of going to any kind of weather station asking for, well, how was the weather in Rotterdam yesterday at 8 o'clock or something like that, we are working on incorporating the real live feeds from that. But also we need to be very clear about these topics, and it's clear that we need to make sure that we do not mix up the areas of competence from the different information. So while we are getting, if I'm asking the weather station, what was the weather in Rotterdam, then I get it one value for the whole city, versus we are going to have cubes of a meter, versus we are getting spot values from sensors. And of course, this is also kind of a challenge to figure out what is the right balance between how these values link to each other to do not generate indications which are simply wrong because they are not matching.
Yeah, for sure. One of the questions I want to make sure we answer, it's just come into the chat, is looking at smaller and less advanced cities and towns and how they can access capabilities such as those that we've been seeing in this session, and how they can build capacity, get their data ready, and also, you know, make the case for investment in this kind of technology as well. Because one thing that we're always looking to do at Smart Cities World is look and see what the possibilities are to start these projects in cities of all sizes and at all scales. I don't know who wants to tackle that first, but I feel like you probably all have something to say on it. So maybe I just pick someone and we go from there. Niels, you have a hand up. That's a good start.
Yeah, I would love to answer this question, because in the Netherlands, and especially Rotterdam, has been for probably 12 years working on digital twins, 3D cities. And in the Netherlands, we have also lots of smaller cities and municipalities. But the adoption of using digital twin technology is still quite low. And the reason is because of this question. People don't know where to start. So we have been working on to make the threshold as low as possible. So in the Netherlands, we have many companies working together in showing everybody that using this technology really does work, that really helps in lowering the cost, really helps in faster decision making because of these prediction models. And what I would like to advise is just start small. Think big what is possible, but just start. There's loads of technology that you can use for digital twins. And just try it. Start with some 3D data, start with some point clouds, and start with some BIM models. The easy, fast profits in usage of digital twins is showing where new buildings will be placed. And you can show people in a digital twin the actual virtual situation of what will happen in the future. And those are just small steps. And every time you take a small step, you will create something bigger. There's no possible way that you can, in the future, say, I'm going to buy a digital twin and it's completely done. You have to grow into it.
Yeah, for sure.
So hopefully that answers the question. Just start small.
Yeah, for sure. And Corne, maybe you can add to that and just tell us a little bit about your experience as well, and how you have managed to, I suppose, build incrementally. It's a big part of the mystery sometimes is the process, right?
Yeah. Yeah, well, the thing is, we just started in Rotterdam, and it's just inside of the DNA of the true Rotterdam civilization. I mean, we all are familiar with just putting in the labor and start doing it and learn by example. It's somewhat what Niels said, start small, think big. We just started with the whole 3D city modeling principle without knowing what exactly we were going to use it for. But in the end, someone just thought, well, I'm not sure what we're doing with it, but I think we need it sometime, somewhere, someplace. And that just paid off for us. But in order to make this scalable for other cities as well, we are now working together with the OASC on writing replicable recipes for the digital twin solution that I just showed in the demonstration. What we do in that is you just see it as a recipe, as part of a cookbook. I mean, I'm not a baker myself, but I know how to follow a recipe, and I know how to bake an apple pie on my own by using the right ingredients and all the components, and I know how to use the oven, and I know how to address the right temperature, and etc. And then in the end, it just pays off. It just works for you, and that's what we are now trying to describe. So we have the ecosystem, we have all the components in place, we have all the configurations set up. We can just write it down as a recipe where you have all the components, you have all the configurations, and then you have some sort of a workflow on how to combine everything into a working solution for you. And that's what we're now trying to achieve. We're doing this together with the city of Den Bosch, since it's also a Dutch municipality. So for the semantics part that we also addressed, that's quite nice and quite familiar for us. But we're also trying this out with Tampere, a Finnish city. And the information model we need underneath it is quite different, since my Finnish is rusty at best. So I don't know how to address the data sets. But in the end, if we make something truly interoperable, then it's also about the semantics, and it's also about the recipe, so that we can scale it. And in the end, the real aim behind it is that I just want to describe which sort of data services do you need as a municipality, so that you can register those onto our ecosystem. And once you've done that, it should be as easy as just clicking everything together and start working with it. And that's my main ambition, that if you're doing this, it's that replicable that you can just start with it, with only addressing your services to the platform.
Yeah, for sure. Uwe,
One last-
anything to add?
Yeah, sure. The smallest town I'm aware of where we have built a digital twin with a customer is about 8,000 residents.
Yeah.
So, and the largest are, I think it's a region in Spain as well as a Canton Zug in Switzerland. So that's from the spatial extent, the larger ones. And everything in between is on our list. I think the key is when we speak about digital twin, the costs are not coming with a digital twin. It comes with the use cases you want to achieve, and also with the outcome you expect with these use cases, which are obviously need to match the use case and the effort and the investment. So you have some static elements like the 3D models. You may have them anyhow. And then you have some processing topics depending on what you want to reach and what you want to get. But and we have done multiple things with our customers, and we made also studies like City of Klagenfurt wants to get climate neutral, CO2 neutral. And we made a very fine grain analytics how much saving was caused by the digital twin in terms of CO2 equivalents for the City of Klagenfurt, including the energy you need for the computing of the simulations and the gasoline you need to capture the city. So just to give you an idea how fine-grained this framework can be. So at the end, it's really the question of what are the use cases, and fully agree with Corné and Niels. You should start with something which is tangible and has a need and brings direct value, and then grow over time. Make sure that your platform is an ecosystem like the one from Corné, so that you can really grow over time with functionality and with use cases.
Yeah, great advice. I think it's practical and it's sensible. That's what we like here. We're over time, so we're going to have to wrap things up, unfortunately. But really interesting session. Lots of, again, really practical and insightful comments, and the presentations have been really interesting. It's really nice to see things brought to life in the way that you guys have managed to do it. You don't always get that experience where it feels like you're kind of going a bit more hands-on with things, so I think that's very much appreciated, certainly by me and our audience here. I know there are some questions that we didn't get to, so what we'll do is we'll make sure that we forward those unanswered questions onto the speakers afterwards. We always encourage you guys in the audience to reach out and connect with the speakers of your own accord through LinkedIn or email. And I can see Niels has just put in the chat as well that they will be at Smart City Expo in Barcelona in a couple of weeks' time, along with probably the rest of us. So make sure if you're there, take the time to go and meet them. I'm sure it'd be very much appreciated. But that's all for now. We do have another webinar with Hexagon coming up next month. You can find out more about that on our website and in the link that we've shared in the chat. But for now, thank you all for your time. Very much appreciate it. We'll see you next time.